Welcome back. Today we're going to be looking at NumPy in Python. So what is NumPy? Well, we're not going to fully understand NumPy. You're not going to be an expert by the end of this video. But hopefully you'll understand what it is and you know that you can use it and a few things that it can do so that when you use it in your applications, you know what you're doing. I also hope that after this you go away and have a look at some of the documentation and create your own projects, as this is more of an introduction than something that will teach you NumPy. So what is NumPy? Well, it stands for Numerical Python, and it's a Python library for working with arrays, mostly arrays, but it can do a lot of stuff. So this involves Fourier transforms, sorting, matrix multiplication. They have a whole submodule, in fact, dedicated to matrices. So there's a lot you can do with this, and it's a really powerful tool in data science. So why use NumPy? Why not just use the normal Python framework? Well, I guess the reason is it's about 50 times faster than lists. And if I give you the choice of waiting 1 second or 50 seconds for your code to run, I'm sure you pick 1 second. It has loads of built-in functions, so you don't have to reinvent the wheel. It's used in other libraries, so lots of other libraries will actually be based on NumPy because of how much faster it is, and it's open source. So in fact, if you wanted, you could even contribute to NumPy by writing code for them, which is quite cool. So how come it's so much better? Well, the first thing is locality of reference. So what this means is, in Python, your list is stored in the memory, but it's stored all over the place. What you've got is you've got a list of pointers that point to different places, and in those places you've got stuff stored. Whereas in NumPy, it allocates a block of memory in a certain space, and it's using that it's able to access data so much quicker. It's also optimized for CPU architectures, so it's already been compiled in some cases, which allows you to run it a lot quicker, and it's been written in C and C++ mostly. So you're probably wondering how you can use it in Python, and I'm just going to say that you can, rather than going into all the details. So let's go and have a play with it. So at the start, I want to import NumPy, and it's pretty classical to import it as NP, so that you can just write NP instead of NumPy every time, and that doesn't display anything. I should mention though, when you try this, you'll probably get an error saying NumPy does not exist. So here we want to install NumPy. So you just type in pip install NumPy, and then it will install a bunch of stuff for you. As you can see, I've already got it installed, so it doesn't need to do anything. But for yours, it said download some wheels, extract them, and set up NumPy. And then you can just run your Python code. So now we've got NumPy, and we're going to create a NumPy array. And you can see this one's got 5 elements, so it's not that exciting. This is a different array, and you'll notice it's only got one number. So this is a 0-dimensional array. So that's the only value. You can have 2-dimensional arrays, you can have 3-dimensional arrays, and in fact you can have n-dimensional arrays. And you can see that with this ndim function, it prints out the number of dimensions in our array. And you see I've got 0 being one with 0 dimensions, 1 with 1, 2 with 2, 3 with 3, and so on. So here we've got an array, and it says here we specify the number of dimensions. Note that that's not the same as ndim, it's ndmin is equal to 4. And you can see this is now a 4-dimensional array. It's just we've only got one thing in 3 of the dimensions, so it's not that exciting. And then they all have a shape, and the shape is a tuple that says what they're like in multiple dimensions. So you can see our 0-dimensional array has no shape, pretty much. Our 1-dimensional array just has a shape of 1, and that's 5 long. Our 2-dimensional array has 2 in the first dimension and 3 in the second dimension. And then 4 you can see we've got these ones where we haven't put anything in. So how do you access data? Well, it's pretty much the same as Python. If you want, you can say we can print a second item, we can add stuff together in the same way, or we can reference the first dimension as index 1 and the second as index 2. So fairly simple. However, one thing that NumPy supports is this comma format. So instead of doing this, you just put 1, 2, and you can see here that we've just put commas in for each of the dimensions. And you notice here we've put -1, and that's because just like Python's lists support negative indexing, so do NumPy arrays. So what about slicing? Well, slicing in NumPy is virtually the same as in Python. You just put commas in. So here we've got a colon, which means select everything. Here we've got 1 and then everything afterwards. And then here we've got the last one in reverse. And you can see it's done that. You can also have special data types in NumPy. So in Python you've got int, float, boolean, complex numbers, which we haven't looked at yet, but maybe will, and strings. But NumPy have different data types, and you can see by default it saved them all as 32-bit ints. So the ones they have, the main ones they have, are integer boolean, an unsigned integer, so it can only be positive, a float, a complex float, a time delta, a date time, a string, and a Unicode string. So here we're going to reset all the data types and see if you can figure out what they are. So 0 we haven't changed, so that should remain in 32. One we have changed, we've changed to I2. So you'd think, oh, is that a 2-bit int? But no, it's a 16-bit int, because you've got 2 bytes, so I2. And likewise, F4 is float 32, because it's 4 bytes, which is 32 bits. Array2 has just shortened it because it's trying to store integers as boolean, which doesn't really work. And then the last one it's saved as a complex float. So about making changes, so first we're going to have array 5, and this isn't 5-dimensional, it's got 5 elements, but we've already used array 1. So this is just a simple array. And so what we'll do is we'll copy our array and then print out both of them and the copy. And so what we've done here is we've changed the value of the 2 to 7 in x. And you can see that 5 hasn't changed, but x has. And so now we can print out the base, and you'll see that it says there's no base. And what that means is this is the original. If we make changes to this one, it doesn't affect anything else. But now, instead of copying it, we copy using the view. And you can see this time when we change index 1, it changes it in both lists. So again, you've got something similar to if you have lists in Python. And then this time when we print the base, you see that it says the x's base is this, which is array 5, because it's a view of array 5. And so that's something cool you can do. You can copy the whole array, or you can just create a view of it. You can also reshape arrays, so now we've got an array and it's 0 to 7. And we can reshape it into dimensions 4 and 2. And you can see now it's 4 by 2. We can reshape it into 2, 2, and 2. And you can see it's 2 by 2, and then by 2. And if we try reshaping it into 2, 2, and 3, it fails because that doesn't make sense. And this is an error that you probably get a lot when you realize that your dimensions don't quite work out, and it's a very frustrating error to get. We can also reshape using -1, and what that means is it automatically calculates that value. So you can see there it's immediately known, oh, this has to be a 2 because they have to multiply to 8. But you can only use the -1 once. And then we can turn our 2-dimensional array, you can see when I hover it's coming up, into a 1-dimensional array just by putting a -1 in. And you can see it's kept the data type as well. You can also search through arrays. So if we print where array 2 is a 2, you can see that it's greater than or equal to 2, where you've got 0, 8, 1, 0, 1, 4, 1, 8. And that's because even though it looks like we've flattened it, this is the output of this cell rather than actually changing the array. And so we can actually print out all the values and see they are kind of as referenced here, pairing them up 0, 8, 1, 8, 1, 4, 1, 8, and it gives us all the numbers that are greater than 2. Another thing you can do is you can do some really strange indexing, which I find quite cool. So we print x, which will be true, false, and this basically repeated 4 times. Then we print array 8, and then we use x as an index. So you can see it's gone true, false, true, false, true, false. And so it's gone include this one, don't include this one, include this one, don't include this one. And it's repeated that pattern, and we've actually managed to get them all there. You can also use this where that we've just used up here is indexing. So we can print out 8 where it fits this condition. So we'll just print out all the multiples of 3 in number 8. You also have a random function. So usually what you might do is you might import random, and then you generate a random number 10 times, and you get a list. And I'll just put a star there so that it prints a bit nicer, because otherwise it prints it down the screen. And so this is our list random. And so now we've got an array random, and we can do exactly the same. We just put 100 as our max, and there we go. We've got some random numbers between 0 and 100. And so let's say that we want to sort our random list. Well, Python has a built-in sort function. So in this code, we import time. We get the current time. Then we have this random list, which we set to a random number. And you see we've done this 10 million times. And this is going to take a while to sort, by which I mean 10 seconds rather than 100th of a second or something. We sort it, and then we figure out the time to sort our list. And so we can just wait for that to run. And you can see it's taken 12.9 seconds to sort that list. So then with NumPy, we do the same. We use the time module to do this time. We generate 10 to the 7 random numbers between 0 and 100, and then we sort them, and we see how long it takes. And that was a lot quicker. And we can actually see, we run this bit at the bottom, that it was about 25 times quicker using NumPy. And I said initially it was 50, but it's up to 50. And there are other things that NumPy does even quicker. So it really is a powerful tool. And as you saw, this took a very short amount of time. And you could probably have skipped forward in the video without missing much in the first one. So hopefully you see NumPy is a really powerful tool, something that you can use everywhere, and is really important in data science, which is one of Python's main uses. And you're using code that's been written in C++ and C in Python. So you don't have to know any C++ or C, but you've still got some really fast code. So hopefully you've enjoyed this video as well, and I'll see you again same time next week. Till then.